তাৰপিছত ছাৰে ক'লে
So hello students, we'll continue with unit number 2 and topic number 2, which is Introduction to Transportation. The first half regarding transportation we already did in our last class. We'll continue with the same. And futuristic system, the type we'll discuss here is Hyperloop. So, airports. An airport is an aerodrome with extended facilities, mostly for commercial air transport. Airports often have facilities to store and maintain aircraft and a control tower. An airport consists of a landing area, which comprises an aerially accessible open space, including at least one operationally active surface, such as a runway for a plane to take off or a helipad, and often includes adjacent utility buildings such as control towers, hangars, and terminals. Larger airports may have airport aprons, taxiway bridges, air traffic control centers, passenger facilities such as restaurants and lounges, and emergency services. In some countries, the US in particular, they also typically have one or more fixed base operators serving general aviation. An airport solely serving helicopters is called a heliport. An airport for use by seaplanes and amphibious aircraft is called a seaplane base. Such a base typically includes a stretch of open water for takeoffs and landings and a seaplane docks for tying up. Hartsfield-Jackson Atlanta International Airport in USA is the busiest and biggest airport in the world. An international airport has additional facilities for customs and passport control, as well as incorporating all the aforementioned elements. Such airports rank among the most complex and largest of all built typologies, with 15 of the top 50 buildings by floor area being airport terminals. Next, seaport. A port is a maritime facility which may comprise one or more wharves where ships may dock to load and discharge passengers and cargo. Although usually situated on a sea coast or estuary, some ports such as Hamburg, Manchester, and Duluth are many miles inland with access to the sea via river or canal. Because of their roles as a port of entry for immigrants, many port cities such as London, New York, Shanghai, Los Angeles, Singapore, and Vancouver experience dramatic multi-ethnic and multicultural changes. So today, by far the greatest growth in port development is in Asia, the continent with some of the world's largest and busiest ports, such as Singapore and the Chinese ports of Shanghai and Ningbo, Zhoushan. The terms port and seaport are used for different types of port facilities that handle ocean-going vessels, and river port is used for river traffic such as barges and other shallow draft vessels. 1. Dry port, 2. Fishing port, and 3. Inland port. A seaport is further categorized as cruise port or a cargo port. Additionally, cruise ports are also known as home port or a port of call. The cargo port is also further categorized into a bulk or break bulk port or as a container port. Riverways. Water transport in India has played a significant role in the country's economy and is indispensable to foreign trade. It has the largest carrying capacity of any form of transport and is most suitable for carrying bulky goods over long distances. It is one of the most cheap modes of transport in India as it takes advantage of natural track and does not require huge capital investment in construction and maintenance except in the case of canals. Its fuel efficiency contributes to lower operating costs and reduced environmental impact due to carbon. India has 14,500 kilometers of inland waterways, out of which only 5,685 kilometers are navigable by mechanized vessels. India has an extensive network of inland waterways in the form of rivers, canals, backwaters, and creeks. The total navigable length is 14,500 kilometers, which is 9,000 meters, out of which about 5,200 kilometers, which is 3,200 meters, of river and 4,000 kilometers, which is 2,500 meters, of canal can be used by mechanized crafts. About 44 million tons, that is, of cargo are moved annually through these waterways using mechanized vessels and country boats. Cargo transported in an organized manner is confined to few waterways in Goa, West Bengal, Assam, and Kerala. Inland waterways consist of the Ganges, Bhagirathi, Hooghly rivers, the Brahmaputra, the Barak river, the rivers in Goa, the backwaters in Kerala, inland waters in Mumbai, and the deltic regions of the Godavari, Krishna rivers. Next, sea canals. Canals are waterways, channels, or artificial waterways for water conveyance or to service water transport vehicles. They may also help with irrigation. It can be thought of as an artificial version of a river. In most cases, the engineered works will have a series of dams and locks that create reservoirs of low-speed current flow. These reservoirs are referred to as slack water levels, often just called levels. A canal is also known as a navigation when it parallels a river and shares a part of its water and drainage basin and leverages its resources by building dams and locks to increase and lengthen its stretches of slack water levels while staying in its valley. In contrast, a canal cuts across a drainage, divides a top or ridge, generally requiring an external water source above the highest elevation. Many canals have been built at elevations towering over valleys and other waterways crossing far below. Canals with sources of water at a higher level can deliver water to a destination, such as a city where water is needed. The Roman Empire's aqueducts were such water supply canals. The last one of the transportation is tunnels. A tunnel is an underground passageway dug through the surrounding soil, earth, or rock and enclosed except for entrance and exit, commonly at each end. A pipeline is not a tunnel, though some recent tunnels have used immersed tube construction techniques rather than traditional tunnel boring methods. A tunnel may be for foot or vehicular road traffic, for rail traffic, or for canal. The central portions of a rapid transit network are usually in the tunnel. Some tunnels are aqueducts to supply water for consumption or for hydroelectric stations or are sewers. Utility tunnels are used for routing steam, chill water, electrical power, or telecommunication cables, as well as connecting buildings for convenient passage of people and equipment. Secret tunnels are built for military purposes or by civilians for smuggling of weapons, contraband, or people. Special tunnels, such as wildlife crossings, are built to allow wildlife to cross human made barriers safely. Tunnels can be connected together in tunnel networks. Next topic is futuristic system. The type is Hyperloop. A hyperloop is the proposed mode of passenger and freight transportation first used to describe an open source Vectrian design released by a joint team from Tesla and SpaceX. Hyperloop is a sealed tube or system of tubes through which a pod may travel free of air resistance or friction, conveying people or objects at high speed while being very efficient, thereby drastically reducing travel times over medium range distances. Elon Musk's version of the concept, first publicly mentioned in 2012, incorporates reduced pressure tubes in which pressurized capsules ride on air bearings driven by linear induction motors and axial compressors. The Hyperloop Alpha concept was first published in August 2013, proposing and examining a route running from the Los Angeles region to the San Francisco Bay Area, roughly following the Interstate 5 corridor. The Hyperloop Genesis paper conceived of a Hyperloop system that would propel passengers along the 350-mile route at a speed of 760 mph, which is 1200 km per hour, allowing for a travel time of 35 minutes, which is considerably faster than current rail or air travel times. Preliminary cost estimates for this LASF suggested route LA means Los Angeles and SF is San Francisco, suggested route were included in the white paper of $6 billion for a passenger-only version and $of 7.5 billion for a somewhat larger diameter version, transporting passengers and vehicles. Although transportation analysts had doubts that a system could be constructed on that budget, some analysts claim that a Hyperloop would be several $billion over budget, taking into consideration construction, development, and operation costs. The Hyperloop concept has been explicitly open sourced by Musk and SpaceX, and others have been encouraged to take the ideas and further develop them. To that end, a few companies have been formed and several interdisciplinary student-led teams are working to advance the technology. SpaceX built an approximately 1-mile-long subscale track for its pod design competition at its headquarters in Hawthorne, California. So that's all for this lecture. We'll go through a video. You can give your name, enrollment ID, and section in the chat box for your attendance. Thank you.
This is the future of high-speed transportation. It's 3.5 times faster than Japan's Shinkansen bullet trains, and even faster than a Boeing 747. It's a hyperloop, magnetic pods levitating inside a tube at more than 1,000 kilometers per hour. In theory, you could go from LA to San Francisco in just 45 minutes, with tickets less than $100 one way. This technology could make working and living in two different cities a norm, while also creating a world with less congestion and pollution.
Yes!
And with a successful human test ride in November 2020, we could be less than 10 years away from it becoming reality. The concept of the Hyperloop became widely popular in 2013 thanks to Elon Musk's 58-page Hyperloop Alpha paper that outlined the design, cost, and safety of the concept. But the technology to bring it all together commercially was only recently fine-tuned, namely magnetic levitation, or maglev. Maglev is basically what allows a Hyperloop to go incredibly fast, thanks to the lack of friction between the passenger-carrying pods and the tube-shaped track. The general concept is simple. Magnets lining the bottom of the pod repel the tube material, levitating the pod as it runs.
As an engineer, I always get very excited about talking about magnetic levitation, electromagnetic repulsion.
That's Josh, a mechanical engineer who previously worked at SpaceX. He's now the co-founder and CTO of Virgin Hyperloop. And this is Chuck. He's the lead engineer at a different Hyperloop company, Hyperloop Transportation Technologies. They're both currently developing the best combination of magnets to create the smoothest ride possible, using passive or active maglev. Passive maglev uses permanent magnets in a specific configuration to create a constant magnetic current that levitates the pod, similar to the magnets you might have played with as a kid. Active maglev uses a combination of permanent magnets and electromagnets, the latter which can manipulate the electric current and the strength of that current.
Basically, if I get too close, I drive it one way. If I get too far, I add some strength. And so you can kind of think of it as balancing out. And so if there's bumps in the track, if there's all this, I have a system which we basically use as an active control system to make that ride smooth.
And while you might think this sounds similar to existing maglev trains, the Hyperloop concept removes a key element that holds a lot of trains and planes back: air resistance.
If you ever stick your hand out a window when you're driving in a car, imagine if there was really no air there, you really wouldn't feel that force pushing back your hand. And the same thing can be said for a Hyperloop.
This is where vacuum pumps come in handy. Both companies are installing pumps along the tube. For Hyperloop TT,
the vacuum pumps in our case are developed by Leibold, which invented the vacuum pumps about 150 years ago, so they have a lot of experience.
These pumps, located every 10 kilometers, theoretically would suck out 99.9% of the air between the capsule and the tube. Removing air drag could be the difference of some 800 kilometers per hour.
Theoretically, you could go even faster than the speed of sound, but that's toying with some fun things that we'll do later on.
It's going to take a little bit more time before we go supersonic, though. First, the companies have to prove the tech is safe, which is why this scene is so important.
Yes. Yes.
In November 2020, Josh and Sarah from Virgin Hyperloop became the first people to ever ride a Hyperloop. The two-seat prototype Hyperloop traveled 500 meters, reaching 172 kilometers per hour within 6.25 seconds.
You felt a bit of force back in your seat. You really couldn't even notice the levitation. Like, you didn't notice it pick up. But what you did notice is there wasn't that kind of jerkiness. The camera didn't do it quite justice because the camera was bouncing around a bit more than we were. And it was, a little bit more of like a cushion or like a pillowy type of feeling. You could process everything that was going on around you. You're basically coasting and you're floating on an idea that was nothing more than something on a piece of paper not all that long ago.
While the ride proved its safety, the company wants to work more on the experience. And the actual Hyperloop will be much bigger, too, holding 28 or more passengers, with the ability to move 30,000 passengers an hour. But to get to this point, there will be more testing involved for both companies.
Lots of things have to happen between now and then. The Hyperloop construction, the route is one thing. The integration with the stations is another. And that takes a partnership with the communities.
And Hyperloop TT is currently in the works to build and test a full-size project in Abu Dhabi. Its first potential U.S. project will run from Chicago to Cleveland. Virgin Hyperloop will be building its new certification testing facility in West Virginia in 2022, including a 9,600-meter track to be used for testing and establishing regulatory and safety guidelines.
Around 2025, we're intending to certify a fleet of vehicles, of the 28 passenger vehicles.
Virgin Hyperloop has plans in Dubai, India, and more, with stateside plans for the Midwest, North Carolina, and Texas. But both of these U.S. projects won't be complete until around 2030, which might sound like a long time, but airplanes took about 16 years to really get up and running. And the first high-speed rail in Japan took at least a decade of development. So some 15 years for a Hyperloop doesn't seem that far off. After all,
how can we be a 22nd century country when we're built upon the technology of the 19th century, upon the 20th century? A single lane of Hyperloop can do in excess of 30,000 passengers. What are you going to invest in? What's the thing that you should invest in that allows you to get the future demand, the future needs that you have? A shift is possible if we choose to embrace it.